Okay, module 7 is about the flow processes for the devices. And the course outcome is the ability to acquire and explain the basic concepts in thermodynamics, to comprehend and apply the concept to the actual conditions and problem in closed and open system, and apply and correlate the concept with the appropriate equations and principles to analyze and solve engineering problems. So by the end of the chapter, students should be able to explain and to solve energy balance problems for common steady flow devices such as nozzle, compressors, turbine, and throttling valve. In this module, we will cover about the energy analysis of steady flow systems and the throttling process for isentropic expansion in nozzles, compressor, and expander and turbine. Okay, steady flow engineering devices, the examples such as turbines, compressors, heat exchangers, and pumps. So this is conveniently analyzed as steady flow devices. Okay, and also throttling valves at here. Okay, nozzles and diffusers. So this is a diagram of nozzles. So it's kind of a similar with diffuser. The difference is the cross section area. So look at this. This is level 1, this is level 2. It means in this is the inlet, this is the outlet. So look at the cross-section area at here. The nozzle coming from a bigger cross-section area at state number 1 and lower cross-section area at state number 2. So your volume 2, okay, your specific, the velocity, the velocity at number 2 is bigger than V1. Why? Because velocity coming from higher cross section is lower velocity compared to the lower cross section area. So we have the velocity is increased when you go through a lower cross section area. Okay, the same goes for diffuser. Okay, the fluid coming from state number 1 at here and state number 2 at here, from lower cross section area. So we have V1 at here, velocity 1 at here, which from lower cross section to higher cross section. Therefore, okay, so you speed up first and then getting lower velocity. So V2 is actually lower than V1. Okay, so the velocity will increase, will speed up at a lower cross section area. Okay, so nozzle and diffusers are shaped so that they cause large changes in fluid velocities and thus kinetic energies as well. So nozzles and diffusers are commonly utilized in jet engine, rockets, spacecraft, and even garden hoses. Nozzle is a device that increases the velocity of a fluid at the expense of pressure. Nozzle, okay, increase the velocity, so from lower to higher velocity. So this is increasing the velocity. But a diffuser is a device that increases the pressure by slowing it down, by slowing the velocity down. Okay, so the cross-sectional area of a nozzle decreases in the flow direction for subsonic flows and increases for supersonic flows. So the reverse is true for diffuser. So the cross-sectional area must be different for nozzle and diffuser. So this is the energy balance for nozzle or diffuser. E in equals to E out by assuming this is a steady flow. Okay, so E in, rate of E in equals to rate of E out. So we have the same equation, but this one for inlet, this one is for outlet. Okay, since Q equals to 0, there are no heat being there are no Q in or out. Okay, and work, there are also no work involved in this case. So Q equal to 0, work equal to 0, and delta PE is equal to 0. That's why what's left is only about the okay, Q and work is equal to 0, and there are no potential energy. What's left is only about MH and kinetic energy. Okay, so this is what's left. Okay, nozzle and diffusers. So this is energy balance for nozzle diffuser. It can be applied for both devices, okay, but the value must be different, right?